So you say there are 11-year cycles? Is that exact or is it average
No,
estimate?
no, no. It's like the stock market. There are lots of cycles within the cycles.
Yeah.
So the shortest cycle is 11 years. There is also a longer cycle, which is 100-ish, 110 years.
Ish.
Yes.
So the 11 is ish too? 11-ish?
Well, because it's short and we have lots of observations, we can easily define it. But we don't have observations over, say, 1,000 years to define the long-term cycle. We can define the short cycles really well, but we
So you
don't
can
have
predict
define it.
when the
Yes.
next cycle will be
Yes.
pretty much...
So we know that we have 11-year cycle, minimum, maximum. Thing is, the maxima are not of the same strength.
Okay, so that's
When you
the
look back at the
variation.
history, when you go back to 17th, 18th century, you see that we had maxima, but they were very shallow. Okay, so from that time, 2 centuries ago up until now, the strength of the maxima had increased. And now the big question is whether we are at the peak of the maxima or we start to go downhill. Because if you haven't reached the peak of the maxima, if they continue to get stronger and stronger over time, that's bad news for us.
So is that dependent on the fuel of the sun? I mean, will it, as the sun starts dying?
No, that depends on the magnetic dynamo process that happens in the convection zone.
Do we know what the characteristic parameters that govern these cycles? Well, I assume these are some characteristic frequencies of the system.
Well, that again depends on the magnetic dynamo. So what they try to do is find what the characteristics scale that this dynamo processes. But the thing is, we don't have good enough observations to pin it down. We have lots of simulations, but they depend on too many unknown parameters.
Is it the cycles dependent on the magnetic field, right? Flux.
Yes, the magnetic field is generated by a magnetic dynamo process that happens in the convection zone, and that's where many question marks are.
But it's
So-
the field flips every 11 years.
Yes, it does.
That's what's done.
Yes, magnetic field will flips every 11 years, but the thing is, within these 11 years, you may have, say, 100 sunspots, or you may have 500 sunspots. That's the thing. You still have the same periodicity, but you have different amplitude of the
So
cycle.
is the flipping on the magnetic field completely understood? Why the field flips?
Yes, magnetic field will flip. So during solar minimum,
But is
magnetic
it
field is like
understood?
magnetic dipole.
Do they understand why it does that? Why it flips? Is that well understood?
It's not very well understood.
Just like the Earth.
Yeah, just like the others. We know that there is a large-scale dynamo process working. So you have,
What does that mean? What does large-scale dynamo process mean?
you have the differential rotation. You have this large shear layer between the radiation zone and the convection zone. So if you have purely poloidal field and you have differential rotation, that will create a very strong azimuthal field along the solar equator where it moves. So if you have pure poloidal field and you have differential rotation, it will tend to create azimuthal field out of it. But then you have also differential rotation that changes in depth. So if you create this field and you have differential rotation that works in depth, you have constantly twisting, you have reconnection, so you intensify the field, you constantly isolate a small patch, or you constantly twist more of it. So you have differential rotation that is function of latitude but also in depth, and you also have some meridional flow. So due to the differential rotation, you create a azimuthal field, and then when you have meridional flows coming from the equator towards the poles, that's how you create poloidal field out of the azimuthal field. So it's a complex alpha, omega type of.
Can I answer this question?
Yes.
In this differential flow,
Yes.
do the relative velocity increase with time? If it does, then it seems to me that it will reach a point where this shear stress so big that it will reverse the flow direction. I mean, imagine you have something that's twisting inside and other things. if you twist enough, then it will go back the other way. Is there evidence that this differential flow changes within this 11-year cycle?
No, we didn't
So-
find
so
any
it-
significant change.
So it's a constant velocity?
The thing is, we discovered this shear region between the radiation zone and the convection zone not long ago. We
Okay.
have observations for how many years? Since 1995. So we have observation only for one solar cycle.
Right, but it seems to be, if
Sure.
it reverse, at some point the velocity have to zero and
Let's
then go
put it
back.
this way: we don't
Go
have
back.
long enough observations to determine how things are going to change from one cycle to another.
Okay.
We have basic observations over the last solar cycle, detailed observations,
I
not just
see.
in the kernel but also inside the sun. So in order to know what's going to happen, if you want to see how things are going to evolve over a number of solar cycles, we need more
Well, just-
long-term
Yeah,
observations.
sure. 4 or 5 more graduate students.
I agree.
5 years of PhD, that's like 4 cycles.
Yeah. We got the data, we just need more people to work on the data.